Peterson's solution requires two processes to share two data items. First turn, next blame. Okay. The variable turn indicates whose turn it is to enter its critical section. That means if turn equals to I, then process PI is allowed to execute in its critical section. The array flag is used to indicate if a process is ready to enter its critical section. With an explanation, so we look at this is process PI, the pseudocode. This is process PJ, and this block here is the enter section, and this is critical section, and this block, this statement is exit section. Of course, as for process PJ, this is enter section, and this is exit section. So let's look at the enter section. Process PI first sets flag I to be true. That means PI is ready to enter its critical section, and sets turn to the value J. That means it's the turn for process PJ to enter its critical section. And the while statement will test if flag J equals true, and at the same time turn equals J. That means process PJ is ready, and also it's its turn to enter its critical section. So process PI just has to wait, do nothing, and loop again, testing the condition until the time select expires, and then process PJ begin its execution. Okay, so if the condition, these two conditions doesn't satisfy at the same time, that means only such as flag J equals to false or turn equals to I, then the process PI can enter its critical section. After finishing critical section, then set flag I equals to false. That means process PI is not ready to enter the critical section. So if both processes try to enter the critical section at the same time, and then we know that the turn will be set to both I and J at roughly the same time, but only one of these assignments will last. That means only one assignment will do. So if turn equals to I, then process PI can enter its critical section. After it finishes its exit section, then process PJ can enter its critical section, and vice versa. So now let's prove this solution is correct. We need to show that it satisfies the three requirements for critical section problem: mutual exclusion, progress, and bounded waiting. Okay, so let's look. As for mutual exclusion, of course it is, because turn can only equal to one value. If it equals to I, then process PI can enter its critical section. If it is equals to J, then process PJ can enter its critical section. And both PI and PJ cannot execute critical section code at the same time. Only one process can enter its critical section. And about the character 2, progress, that means if process Pi doesn't want to enter its critical section, then flag I equals false, because we initialize flag I and flag J to false. So if process Pi doesn't want to enter its critical section, then flag I equals to false. So this while condition doesn't satisfy at the same time. These two conditions cannot satisfy at the same time. So process Pj can enter its critical section and vice versa. How about bounded waiting? If process Pi and Pj want to enter their critical section at the same time, then both of them will wait at while statement. Just now we say because turn can only equals to one value at any time. So if it equals to I, then process Pi can enter its critical section. After that, at exit section, flag I is assigned false, then process Pj can pass here this while statement, then can enter its critical section. So this is bounded waiting.